I'm going to start here with this function that I have here. So y equals 1.01 to the power of x. You can see that this function, what it does is I'm using the multiplier for increase of 1%. Okay, so what this function will do is if I was to repeatedly increase by 1%, I can find what the actual increase value would be. So, for example, I can say if I was to increase something by 1% twice, what I would have is 1.01 to the power of 2. Okay, and that will give me my y value. So when x is equal to 2, what would my y value be? So I can simply calculate this, and this will give me 1.0201. Okay, so if I increase something by 1% twice, compounded, I actually increase it by 2.01%. Okay, so this is what this function is doing. Now, how about if my problem was such that I have to know how many times I need to increase an amount by 1% to get 5%. So this calculation here. So for this, we need to do the opposite of what I'm doing in this function. Now, the opposite of this, for us to do that, we need to redefine and find something else that, find a new function that actually works this out for us. Now, this new function is going to be log. Okay, so I'm going to write that down first. So I'm going to go, if I did log, so log with base 1.01, so notice how this is the base here, and this is going to be of 1.05, and find this value. This will give me my value for x. Okay, so if I put that in my calculator, what I get is 4.903 to 3 decimal places. Okay, so that's the value. So if I raise this power, 1.01 to 4.903, I get something close to 1.05. This is because I approximated here. Okay, so this is actually an approximation. So this is a new function that we need to know, okay, and it's the reverse function of raising something to a particular power. Now, I want to draw a parallel here before I move on. So I'm going to go with the function y equals x squared. So y equals x squared. So, for example, if in this case, if x is equal to 2, what we would have is y is equal to 2 to the power of 2, and I can get the value 4, okay? But how about I wanted to know what x is when y is equal to, let's say, 49, okay? So it's 49 here, and it's x squared. So notice what I've done is quite similar to what I did here, okay? So I wanted to know the y value. For what particular x value would I get this y value? Okay, so for what particular x value will I get this y value? That's what I'm doing here as well. And I know that to find this value, what I would do is I would square root. Okay, so I would square root the 49. So that's because the square root is the opposite of squaring. Okay, so I will square root the 49. You can say plus or minus as well. Square root of 49 is 7. Okay, so notice that this is doing the inverse. Okay, so this is like doing the inverse. Now, what I'm going to do now is I'm going to show you what the inverse function will be. Okay, so in this case, we would have y equals log with a base 1.01 of x. Okay, so this is the inverse function here. Now, I know that looks complicated, but I'm going to do it on this example as well. The inverse function of this would be the square root of x. So y equals square root of x. So what I want to do next is I want to show you a couple of functions, okay, some with log and some that we're more familiar with, and show you the function and their inverses so that we can get that idea in our minds. So here I have some new functions, so exponential functions here, and their inverses in logs on this side. So what I want you to pay attention to is how this is formed. So this base 2 comes here, okay, comes the base there, and we're doing the function for this x value here. So log of base 2 of the x, okay, and then notice how this one has changed here, and this one has changed here. Now this last one is sometimes also written as, so this also can be y equals log x like that. So when you see log x, normally we assume the base is 10. Okay, so this is something else to know there. Now what I want you to do, what I want to do now is show you some more functions, some basic ones. So for example, y equals x plus 5. So the inverse function here would be y equals x take away 5. Or let's say, for example, y equals 2x take away 3. The inverse function would be y equals x plus 3, all of that divided by 2. Now, just for you to really hopefully see it in another way and, hopefully increase your understanding a little bit more, I'm now going to change the notation as well. So I'm going to rewrite this one in function notation. So that first one, I could have said here, f of x is equal to 2 to the power of x. And then the inverse function is normally denoted like this, f of minus 1x, like that. And that would be log 2, and then x like that. Log with base 2, log of x with base 2. Okay? So notice how this is what we really mean. We actually mean that this really is the inverse function of this one here. Okay, right now what I'm going to do is write some equivalent expressions, or equivalent equations to these. Okay, so these and these, and we will find the value of these ones. Okay, so this first equation, you can see that it is correct. 2 to the power of 4 is 16. Now I can write an equivalent equation using logs here. So this would be log of 16 with base 2, and the value for that would be 4. Okay, so notice where the 4 goes here, 16 comes here, and the base is here. Okay, I'll do the same again here. So this time it will be log with a base 3 of 27, and the value is 3, because this is what the power is. Okay, that will go there. This time the equation is in log, and I need to write it in index form. Okay, so it's really going the other way around. So this would be 2 to the power of 5 is 32. Okay, and the next one here, this will be 100 to the power of a half is equal to 10. Okay, and now finally we want to find the value of these. Okay, so how do you do this? So what we need to do is we need to think about what do we need to raise 3 to the power of to get 9? That would be 2. Okay, so this one would be 2. Okay, next one here, what do I need to raise 10 to the power of to get 10,000? That would be 4. And this final one, it looks a little bit more harder. Okay, so because this one looks harder, I'm going to rewrite this as an equation to be solved. Okay, so just for it to be easier for me to see. So this would be 2 to the power of something is equal to 1 over 16. Okay, now I know that this power would need to be negative so that I get the reciprocal. And then it would need to be negative 4, because 2 to the power of 4 is 16. So in this case, this would be negative 4. Now here are some for you to try. So really it's the same questions. You have to rewrite these equations as equations with log, and then rewrite these ones in index form, and then find the value of these.